Hello friends, welcome back to my channel. In this video we are going to discuss about the mathematical logic chapter from the class 12. In this first topic is about statement. What do you mean by statement? So the statements are declarative or assertive sentences which can either be true or false. Okay, so that means that sentence which has the truth value either true or false is known as statement. For example, sun is planet. This is the statement which has the truth value. Think it is false because sun is not a planet. So the statement can be also like this: x plus 3 is equal to 5 and given is x is equal to 1. This is also statement which has truth value. What will be the truth value of this statement? That is x plus 3 is equal to 5, and where the value of x is 1, the truth value will be calculated as, means that here we can replace it by 1 plus 3 is equal to 4, which is not equal to 5. So the truth value of this statement is false. Okay, so I have to also mention over here that truth value, that is true or falsy, is denoted by capital F and T. This is for falsy and this is for truth. So, and this, they are also known as truth value. So now, which one of the followings are not the statement? So open sentence is not a statement. Exclamatory sentence are not a statement. Open sentences means that it is, this chalk is of yellow color. This is the open sentence. Or we can say it as it is a pink color. It can be pink color or it cannot be pink color. This is open sentences. Now we will take one more example of the statement that could be like similar to this example, x plus 3 equal to 5, where x is not mentioned over here, and it is statement or not, guess it. And if it is a statement, then why, according to which basis you are declaring that it is a statement? So this is not a statement because it can either be true or false. If I kept the value of x here as 2, then it will become true. And if I kept the value of the x over here 1, then this statement will not become true. That means it has the both value, either it can be true, either it can be false. That means mean by statement. But this statement has any value. It can be true, it can be false. So this is not a statement. So you can also note down this example. Then there is one note, that note is every standard formula identity are always true statement. For example, this is the standard formula, sin square theta plus cos square theta equal to 1. So it is a statement which has truth value. What is the truth value of this? And that is equal to t. That is, means the every standard formulae identities are always true statement. Another example will be sin 2 theta is equal to 2 sin theta cos theta. This is also an formula which is also a statement, and its truth value is true, that is T. Then there is one more example. Example is, may I help you? Question mark. So it is not a statement because it is an interrogative sentence. So interrogative sentences are also not an statement. Then do not disturb. Do not disturb is also not a statement because it is an imperative sentence. So we have one more statement for you, that is x square minus 9 equal to 0, where x is equal to 3 or x is equal to minus 3. So consider that this x is equal to 3 or x is equal to minus 3 is not given to you. Then tell me whether it is a statement or not. So yeah, sure, it is not a statement because it can also be 0 and cannot also be 0. That means it has value, it can be true or it can be false. But now giving this value, it has become an statement. So it can be either true or either false. So we will put this value of x in this expression and check out the value of it. So 3 square minus 9 is equal to 0, that is 9 minus 9 is equal to 0. Yeah, it is true. Minus 3 square, that is 9 minus 9 is equal to 0. Yes, it is true. So this is a statement and which having the truth value T. Now we are going to learn about the logical connectives. So the first is not, and which symbol is like this, and it is called as negation. But symbol is like this, conjunction, or the symbol disjunction, if then. This dot indicates that the sentence will be like, if Sita is tall then Gita. In that case there is an if and then sentence, then again sentence. If Sita is tall then Gita. So in that case you have to declare the symbol like this, and which means implications. If and only if, necessary, sufficient, then symbol is like this, and which is known as biconditional. So now we had learned about logical connectives. So how we can implement it, we are now going to learn it. So the question is, if P is equal to Sita is tall and Q is equal to Sita is beautiful, then Sita is tall and beautiful. How can you represent it in the symbolic manner? So Sita is tall represent the sentence P, okay, that is P, and represent the symbol of conjunction, and beautiful, that is Sita is beautiful, that is Q. That is, this is the symbolic form of this sentence. The symbolic form is this, and the sentence is Sita is tall and beautiful. Then the second sentence is Sita is tall or beautiful. So what will be the symbolic form of this? So number 4 is, if Sita is tall, then she is beautiful. So this statement denotes P, this statement denotes Q, and what about this if and then? So it denotes implication, that is implies, P implies Q, P implies Q. Then Sita is tall if and only if she is beautiful. So Sita is tall, this is denoting P, and Sita is beautiful, this is denoting Q, and this if and only if is denoted by conditional. So then the symbolic form will become P biconditional Q. Then the sixth one, Sita is not tall but beautiful. Sita is not tall, that means negation of P, that is negative of P, that is negation P. Then but beautiful, but indicates conjunction, then beautiful indicates Q, that is negation P conjunction Q. So this is how in sentences we are going to use logical connectives. So now we are going to learn about the truth table. So the first we are going to learn about negations, which is symbol is like this. So this is a table, basically truth table. So if the truth value is T, then the negation of it is false. If the truth value is false, then its negation is true. So the rules are negation of negation P is equal to Q. Also similar to negation of negation Q is equal to Q. Okay. Quite similar like complement of something. Complement of complement is that also. Then negation of T is false. That means the opposite to truth is false, and the opposite to false is truth. So negation of F is equal to T. These are some rules. Okay. So then next we are going to learn about the truth table for conjunction. So now we have to learn conjunction, which symbol is denoted like this, and PQ, this is truth table. So you can simply remember this as it is the multiplication. Okay, so consider as T as 1 and F as 0. 1 into 0, 0, that is F is 0. 0 into 1, 0, that is F is 0. F 0 into 0, that is 0. In this way also you can learn, but in the paper you have to write T and F. Don't write 1 and 0 over there. So T conjunction T is equal to T. Others are false. You can directly remember like this also. So this is the truth table for conjunction. This is the table for the disjunction. In this the symbol is like V, and in this it is, you can remember this as simply OR operation, that is you can remember it as addition operation. That is 1 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0. In this way you can also remember this, or you can directly learn this as F disjunction F, that is false disjunction false is false, and others are true. Others are true. So this is the for the disjunction. So the next is implication. In this I am going to give you one trick to remember this. or you can say it as it is the table. If there is an TF, then the result will be false. TFF, others are true. This is the symbol for implication. So TT, true. TF, whenever you are finding TF, directly write down false in the front of it. This is implication. TFF, others are true. Next is biconditional, and in this, if the both the inputs, that is if the both the values are of the same type, that is TT, FF, then the output is true. That is FF, T, TT, T. Others are false. So this is about biconditional, and which is represented by this kind of symbol. Now the question may be like this also. You are given with the statement that is P implies Q equivalent to negation P disjunction with Q, and you have to prove that this statement is correct. So how can you prove it? Yes, we can prove it by truth table. So we can construct the truth table of it, and from that columns, all that columns, we can say it as this, and means this side, left hand side is equivalent to right hand side. So we will do it now. So observe this carefully. There are just two variables and one negation. So P, Q, negation of P. T, T, F, F, T, F, T, F, negation F, F, T, T. Then first we will construct for left hand side. P implies Q. For the P implies Q, you have to check this P and Q column. Inside it, only one statement is false, others are true. That is TF. Whenever you are finding TF, this statement is false, directly write down false in front of it. But remember one thing also, this T and this F, this is not valid. First T and then F. This is only valid in implication, not like this F implies T. Many students generally make mistake over here. Okay, so I am telling you this part. So write it over here F, and the rest of the it is true. Okay, so now our left hand side we had constructed. Then you have to construct your left hand side. For that we have negation P over here. Then we had to take just disjunction of it with Q, and disjunction of it I had repeated many times that disjunction is OR, quite similar to OR. So you have logical OR, so you have to take the OR operation over here. So negation P, this one with Q, OR operation FT means for false. Is it true? Is this correct? No, it is not correct. So so Q disjunction, so negation P disjunction with Q is FT. T is there, then directly write down T. FF, F. TT, T. TF, T. So by the column, so name this column. This is column 1, 2, 3, 4 and 5. by the column 4th and 5th, we are getting this 2 left hand side and the right hand sides are equal. Hence we had proved this. So the next problems are, we have to find out the truth value of it. So in the question we are given the data that P is true, Q is also true, and R is false. Then find the truth value for P implies Q disjunction with negation R. So you have to put this value of P Q R in this and obtain the truth value of this. So put this value, T implies T V, that is disjunction with negation R, R is F, negation of it is T. I am directly inserting T over there. So for you I will write it negation of F. So in the next step, T implies T will be what it will be? It will be T. Okay, in implication only T implies F is equivalent to F, others are T. So T implies T will be T. So disjunction with negation of F is T. So T disjunction with T will be T. So the truth value of the statement by the following data is true. So we are going to solve the question. The question is like this: determine the truth value of the following sentence, that is the 3 is odd number and 2 is not prime number. Okay, so this is the question and we have to find out the truth value for this. So how to find out? The solution will start from first identifying P and the Q from this sentence. So here P is 3 is odd number. Then Q is, we will generally consider P and Q as a positive. Means that you does not include the not in that, so that you can easily get the negation of it. Okay, so generally consider positive, so the consider here just a positive statement, that is 2 is prime number. Don't consider this not, we will consider it in the negation of Q. So okay, clear? So here Q is 2 is prime number and negation Q is 2 is not prime number. Okay, so tell me the truth value for the statement P and Q, just for the statement P and Q. So the value of P is given as T because 3 is an odd number, and value of Q is given as also T because 2 is also prime number. Then what is asked in the question is 3 is odd number and means conjunction, that is 3 is odd number, P conjunction 2 is not prime number, then negation q according to our p and q. So this is a logical representation of this sentence. So then we have to insert this value over here, equivalent to t conjunction with negation t, that is t conjunction with what will be the truth value for this. Negation of t will be false. So t conjunction with false is equivalent to false. So you have to also write, so therefore the truth value of given statement is false. So this is a truth value for the given statement. This kind of example are also there, so try to solve this. Now there is a note which you have to write down. According to CET, you have to keep this in your mind that P implies Q, and converse of it is Q implies P. Inverse of it is negation P implies Q, and contrapositive of it is negation of Q implies negation of P. This you have to remember this thing, because in CET they ask you what is the in the short question type, what is the converse of P implies Q. Then many people does not know what is the answer of this, so you must remember this. The P implies is Q implies P. So many times also they can also ask like what is the converse of negation P implies negation Q. Then you have to just remember that you have to just rotate them, and which is equivalent to which is not equivalent actually, which is converse of this will be negation Q implies negation P, and kind of stuff like this you have to remember. So you have to remember these three things: converse Q implies P, inverse negation P implies negation Q, and contrapositive negation Q implies negation P. So the next topic is quantifiers. There are two types of quantifiers. One is universal quantifiers and another one is existential quantifier. So universal quantifier is denoted by this kind of symbol, and existential quantifier is denoted by this kind of symbol. And universal means for all, okay, for each and every all. Then existential means for some values it is satisfying, that is called as existential quantifier. So we will take their examples here. So the examples for the universal quantifiers are universal quantifiers x belongs to so first the set is given here to us 1 2 3 and 4, where universal quantifier x belongs to A, where 2x minus 1 is less than 8. So you have to find out the truth value TB I had written over here of this statement. This means that for all x belongs to A, this set 1 2 3 4, this condition should be satisfied. Okay, so we will put one by one value over here. So first value we will put, that is 1 over here. 2 into 1, that is 2, minus 1, that is 1, that is less than 8. Yes, it is true. Then another second one, 2, we will keep here 2, then 2 is 2 into 2, 4, minus 1, 3 is less than 8. Yes, the condition is satisfying. Then third one, 3 into 2, that is 6, minus 1 is less than 8. Yes, it is satisfying. Then 4 into 2, that is 8, minus 1, and which is less than 8, that is 7 is less than 8. Then the condition is satisfying for all. Then the truth value of it is t. This kind of examples are there in quantifiers. You have to solve them. And then what we have to make this false, then add just 5 over here. If the set is 1 2 3 4 5, then for the fifth one, 5 into 2, that is 10 minus 1, which is not less than 8, then the condition, then the truth value will become false. This means for all, each and every element of that set, the condition should be satisfied. Then we will see existential quantifiers example. One example I will give you for this is for some, that is existential quantifier, x belongs to set A, where state that x plus 4 is equal to 7. Now this is an example of the existential quantifiers. So x, now we will consider the similar set a 1 2 3 4 5, then put the value of this one by one inside over here and check the condition. 1 plus 4 5 is not equal to 7, don't worry. Then 2 plus 4 6, which is not equal to 7, 3 plus 4, which is equal to 7. So for one condition it is satisfying, then its truth value is t. Okay, for some condition, that is if there are 5 conditions over there given, but just one condition is satisfying, some conditions are satisfying, so existential quantifiers are like this. So this is the example of existential quantifier. Now we will study the applications rules of this. So there are some 5 formulas. The first formula is negation of anything is equivalent to that anything. This is first formula. Second formula is negation of first conjunction with second equivalent to negation of first disjunction with negation of second. Third, if you want the proof of this, you can consider P and Q instead of first and second and try to construct that truth table which I had already taught to you in the previous in this video itself. So try to check whether it is right or not, so you can try it by yourself. Then third one is negation of first disjunction with second equivalent to negation of first conjunction with negation of second. Then fourth one, rule number 4 is negation of first implies second is equivalent to first conjunction with negation of second. Then fifth one is negation of first biconditional second is equivalent to first conditional first conjunction with negation of second, first conjunction negation of second, disjunction with, are you able to see it or not? Yes, disjunction with second, second conjunction with negation of first. This one, disjunction with this one. You have to do one thing, that you have to make the truth table for all these 5 formulae over here by keeping the first, second as TF, and by making that truth table from as I have already taught you.